afternoon. I am Marita Kotze, the Senior Education Specialist for Physical Sciences with IMPA. I just want to welcome each and everybody, and I want to say thank you for being here with me on a Friday afternoon. I think it's very nice of you to just log in, and I hope you will enjoy the time with me. I'm just going to give the other learners a few seconds more, a minute or so that they can log in. I see there's still people busy logging in, so just be patient. Right, while we're waiting, I just want to say to you, if you didn't download it yet, you can take time now to download the notes that's in the dialogue, that's in the box. So, to the right, in the handout box to the right, or at the bottom of your screen. Okay. Okay, I think it's time to start now. So yes, again, a very welcome to each and everybody of you. I'm not sure what's happening here on my screen. Sorry about that. Very welcome to each and everybody today, and welcome here. Right, I am the Physical Sciences Education Specialist at IMPA, and physics and chemistry is my passion. So I hope I do have learners with me today that also share my passion. And yes, today I do have another picture for you. Junior wants to be an agricultural chemist, and now did his father said, why did he decide that? He says, why did he decide that? And his mother says, he was inspired by the label of a loaf of bread. Now, I hope at this time, I know physics and chemistry can be a challenge, but I hope you start to enjoy chemistry and physics this year as you busy understanding it. Okay, before we start the webinar, let's cover some of the basics that if you're struggling to hear me, make sure your audio is on and your speaker volume is turned up. You will automatically be muted when joining this session. I'm not going to give any time for questions during this session. I will handle your questions afterwards, so make sure that you write down any questions if you do have any questions, and if you forget to ask any questions, you can ask a question. You can send me an email to academics@impact.co.za, or you can send an email to info@impact.co.za. It's very important, if you're not registered with Impact, if you do want any notes, you can in any case send an email to Impact, the notes that I'm giving during the webinars. And if you do have a problem downloading it, the Impact learners, you can download it from the guided learning platform. So make sure that you download all the handouts, as well as you can the PDF webinar today. You can also download that on the guided learning platform. All right. So you are more than welcome to leave any comments, or make sure that the questions you ask will be relevant. I just want to share some information about the questions that I did receive during the last some questions that I did receive after the last webinar. Interesting questions. I do know that there's learners that's busy struggling with, for example, the chemistry. Make sure that you know your grade 10 work, grade 11s, that you're supposed to learn for in grade 11 as well, that form the basis of your grade 11 work. If you didn't, if you do have difficulties with the writing of formulas or the writing and balance of equations, please download my session, my webinar session for today, and go through that videos or the PDFs, and make sure that you do understand it. Or go back to your grade 10 work. There's also science clinic notes that you can download. So make sure that you do understand the work from last year that you need to apply this year. All right, the knowledge area that we're gonna cover today is wave, sound, and light. And all right, the topic that we're going to cover is 2, 3, and 3D wavefronts and geometric optics. All right, the first thing that we are going to look at is geometric optics. Now, if you look at this picture, you can see there's a reflection in this mirror on the table here, and you can see that it's if we look at it, you can see that some of the people nearest to the table, we can see the faces, but we can see the reflection. Both of the reflections we can see here in the table. All right, image is seen as a result of reflection of light on a plain, smooth surface area, and this photo were taken at NASA. Now, what is happening here? If we think about geometrical optics, what is happening here? Light from the page, as you can see, the photo was on a page, or screen is formed into an image by the lens of your eye. Now, why can you see me and at this stage? It's because of reflection. Reflection, that light fall on my face and are reflected to the screen. So that is why you can see me now, and why each and everybody can see each other, because of light rays being reflected, or and if you don't see something, it's been absorbed. It depends on what is happening with the light rays that form on the specific object. All right, much as the lens of the camera that made this photograph mirrors, light lenses can also form images that in turn are captured by your eye. Precisely what I just said now, the fact that you can see people around you, that you can see a table, you can see light, because of light rays being reflected from surfaces. All right. Now, if we look at a light source, as you can see here, here's the light source. There are different things that can happen with this specific light source. The light rays, remember, light rays are straight lines. There are straight lines forming from the light source. Okay, so the light rays, different things can happen with the light source. Remember, it's not just this light ray here, because one of the light rays will go just straight up perpendicular to the surface, the ray normal to the surface, and this one is not bent, but you will see, though not bent, part of the normal ray is being reflected back into the light ray in any case. So normal reflection is that is a normal reflection. It's coming up from above the source. Say, for example, this is a light source underneath the swimming pool. All right. So now, why can you see the light source? Most of the swimming pools nowadays, the modern swimming pools, they do have light sources at the side of the swimming pool. So what is happening with all the light rays? It's not just only one light ray being reflected or coming from the source. There you can see one of the light rays, some of the light will be reflected and some of it will be refracted. There you can see the more it bends and the more it's being refracted, the more of the light, more parts of the light rays are reflected again back. Right. At that point there, you can see at a certain point that the light ray is forming a 90-degree angle with the normal. And that angle here, for this specific medium, each and every medium can have its own specific critical angle. This is a critical angle. Right. So for the light ray coming from the light underneath the water, there must be a certain critical angle for it to reflect it back into the swimming pool, so that you can see the bottom of the swimming pool. So why? You can see the bottom of the swimming pool because some of it is total internal reflection. We have total internal reflection here. All right. Light striking a medium with a lower index of refraction can totally be reflected. So here are a term that we're going to cover later on, index of refraction. So remember, the index of refraction means if the light striking a medium with a lower index of refraction, then it can be totally reflected. All right. So if light falls on an object, it can be either transmitted, reflected, absorbed, refracted. So what is happening when it's transmitted? The object is transparent, as you can see here. The object is transparent. Reflected, it can either be transparent or light striking a medium with a lower index of refraction. You can also see it's also not transparent, or it can be transparent, as you can see, but light striking the medium with a lower index of refraction. And refracted means that the object is transparent, as we can see here. The object is transparent. Okay. All right. What is geometrical optics all about? Geometrical optics or ray optics describes light propagation in terms of rays. As I explained it just now, we have light rays that's been reflected, and there's a propagation of these rays, all of them on the previous page. On the previous example that I gave you, you can see the rays, something happened with it. So the ray in geometric optics is an abstraction or instrument that can be used to predict the path of the light. Okay, but the different things that we are going to look at in geometrical objects is reflection, speed of light, refraction. Refraction, we have refractive index and normal angles and different angles. The normal angle is 90 degrees of the surface, and then we have different angles as well. All right, Snell's law, the one that you do a practical on. Critical angle that we just covered a bit, but I will discuss it more, and total internal reflection. All right, what is reflection? The first one. If we look here at the light ray that's hitting the surface, that enters the surface, that's your incident ray. Okay, So you have an incident ray and you have a reflected ray. Reflection, this is total reflection. Why? Because your angle of incidence equals your angle of reflection. This is a mirror, as you can see here. Dull side of the mirror is at the bottom. The shiny side of the mirror is at the top. The normal line is the line perpendicular to your surface, and that will always be a 90 degrees angle. All right, and your angle of incidence will always be your angle between the normal and the incident ray, and the angle of reflection will always be the angle of between the normal and the reflected ray. So what must, or what can, if we think about total internal reflection, what must be the optimal thing? That the angle of incidence must be bigger than the critical angle. It must be bigger than the critical angle for in order for it, because else it will give you a critical angle, and or else it will give you an angle of 90 degrees that's parallel with the surface. So what are the two laws of reflection? The incident ray, the reflected ray, and the normal are all in the same plane. As you can see here, it's all in the same plane. The angle of incidence equals the angle of reflection. That is a must. Okay, now what is speed of light? Speed of light in a vacuum is 3 multiplied by 10 to the 8 meters per second. Now 3 multiplied by 10 to the multiplied by 10 to the 8 meters per second. This is also on your formula sheet. This is the number on your formula sheet. You will see that on the formula sheet under the constants. All right, but that is for light in a vacuum, normal light in a vacuum. Now, what about different mediums? What about different mediums? Say, for example, air, water, crystals, whatever. All right, so let us just look here at the speed of light. Air is 3,0 multiplied by 10 to the 8. Ice, 2,29. Water, 2,26. Can you see water and ice, it's near each other? Glass, 2,0. Diamond, 1,34 multiplied by 10 to the 8. There is, can you see there's a decrease of speed of light. The denser the material, the lower the speed of light through that material. A diamond is 1,34, while air is 3,0. There's nothing, no obstacles in air, so that's why it can move easily in air. Okay, so when light moves from one medium to another, the speed changes. As we see here, we have air and we have water. As we have on the previous slide as well, where we do have the different angles of reflection, refraction, and the critical angle. You can see here, if it's moving from air to water, the air is a less dense medium, while water is a more dense area. So from a less dense to a more dense area, the angle of refraction is to the normal. Can you see that? The angle of refraction is to the normal. Right, the angle of incidence is bigger than the angle of, if we go back, can you see angle of incidence or angle of reflection is when it's been reflected, but now we have angle of, that is a angle of refraction, because this is that line is a refracted line. I will discuss that more now, but can you see it is a smaller angle than the angle between the incidence angle here. All right, so here we can see refraction. What is the difference now between refraction and refraction? Here we can see we have two substances, substance 1 and substance 2. Substance 2 is definitely more dense than substance 1. We have the incident ray, the angle of incidence, 90-degree angle. Normal is 90-degree angle with the surface. So what is happening when the ray enters the new substance, enters the new medium that's more dense? The ray is being refracted to the normal. And you see here, to the normal. Angle of refraction is the change in direction of a light ray caused by a change in speed. Why is this change in speed? Because, say for example, if we look now at air and water, say for example, it changed from air to glass. Glass is 2, air is 3. So if it moves from glass to from air to glass, you can see here the ray will bend to the normal. The angle of refraction will be smaller than the angle of incidence. Right. Now we did talk about, I did say refractive index, but what is the refractive index? It is the ratio of the speed of light in air to the speed of light through another medium. So the refractive index is only a ratio that doesn't have any unit. The symbol for refractive index is N. The speed of light is Z. The speed of light C, and the speed of light in the medium is U. All right, so now we have the different mediums, and we see that if we go from air to a more dense medium, the angle of refraction, there it is much smaller than the angle of incidence. There we do have a vacuum, there we have a medium. When it's coming from a vacuum to a medium, it bends to the normal. Okay, now what is the correlation between a refractive index and different angles that we do have? Now Snell's law is about the index of refraction and can also be calculated using signs of angles. This is the sign for an angle, the incident angle or the refracted angle that we do have there. So what is the formula for Snell's law? Actually, we write Snell's law as the refractive index of medium 1, then the angle of incidence of medium 1, and the refractive and then the refractive index, say for example, of the other medium and the angle of the other medium. All right. So let us just look at Snell's law. Here I do have a photo of the practical that you are supposed to do for Snell's law. If you didn't do it yet, it's still a practical that you still need to do. You do have a source. This can be done at home with something like a light. If you do have a light source, like a flashlight, and you cut you put a flashlight in a box. You cut maybe a split through the box, and you just put the flashlight in the box, then you will see that there will be one light ray, thick light ray coming, depending on the box that or the opening that you cut in the box. You can see the light ray is moving through it. You can take your ruler, or maybe a piece of glass or something, or a glass. You can just let it shine through that object and measure it with your contractor. Okay, so measure it so that you are sure that you do know what is the measurements. Measure it accurately. Do it more than once so that you do have more confidence, and see that you do have the right. You do have in any case the measurements correct. Okay. So Snell's law we can define now as it describes the refraction as light strikes the boundary between two media. Between two media, there you can see it. So this is the two mediums, and that are the two angles that you're going to use. The index of refraction of a pure vacuum and of air is 1, and the index of refraction of every other substance is greater than 1. All right, so in the formula, you can, as I explained it on the previous slide, the refractive N1 is the refractive index of material 1, refractive index of material 2, angle of incidence of material 1, and angle of refraction of material 2. All right, here I do have an example that we can work through to see how do you do these calculations. The moment you see that light is refracted at the boundary between water and an unknown medium, if the angle of incidence is 25 degrees and the angle of refraction is 20.6 degrees, calculate the refractive index of the unknown medium and use. Now the table that they're talking about here is also the table that you have. This is the table that we previously, I just cut some of them where you can see the refractive index. So go and look in your study guides. Whichever study guide you use, make sure that you get to that table, and then you can do the practical. Or in any case, if you want to do the calculations, yes, go and source on the internet for a table with all the refractive indexes. All right. Now, what is your first step in the solution? You do know now that it's Snell's law that you're going to use, because you do have an angle of incidence, you do have a refraction, angle of refraction, and you do have a refractive index. You can look that up in the table. So, and you want to calculate the refractive index. So the moment you want to calculate and you have two mediums, then you use Snell's law. So determine what is given and what is being asked. Now the angle of incidence here, write down what you do have. You do have the angle of incidence, you do have the angle of refraction. You can look the refractive index of water, you can look it up in the table. So in your formula, as you can see, you need 4. There are 4 variables here. So if you do have 3, you can do this calculation. All right, so and you need to calculate the refractive index. Where do you start? You write down Snell's law, and Snell's law is on your formula sheet. The formula is on your formula sheet. Write down Snell's law, and then you can manipulate it. Then I cannot state that enough. If you struggle with maths, please don't manipulate formulas if you do not know how to do that. and write the formula as it is on the formula sheet. That's the way it's been written on the formula sheet. Write it as it is. If you manipulate it in step 2 and you do make a mistake in step 2, then you can still have a mark for the formula if that is one of the marking guidelines for this specific test or task is it's what that you get a mark for that formula. You will not necessarily always get a mark for the formula, but please use it as it is on the formula sheet if you're not sure how to manipulate formulas. Right. Then you can manipulate it in the second step, and then you can do the rest of the calculation and get an answer. Here you can see there's no unit because it is just a ratio that we're looking at here. Identify the unknown medium. Now, how are you going to know what's the unknown medium? You can look up in the same table where you look for the refractive index of water. You can look for the refractive index of the other medium. All right, so glass, typical glass has a refractive index between 1,5 to 1,9. So therefore, the unknown medium is typical glass. So it will not necessarily that you got it. Say for example, as this is said here. Say for example, on the table there's a comma 1, and you cannot see any other medium that will come near to that refractive index. Then that will be the one. So make sure how to do the calculation, and then look at the medium. Just look in the refractive index table for the medium. Okay. Now, what is the critical angle? The critical angle, as I explained previously, is the angle of incidence in an optically denser medium for which the angle of refraction in the optically less dense medium is 90 degrees. So the refracted ray travels parallel to the boundary between the mediums. So that's why you do have a 90-degree angle there. There you can see that angle of incidence here is therefore the critical angle of this specific scenario that we do have here. So what is the relationship between refraction, critical angle, and total internal reflection? If we look at these three sketches, we can see let me just explain the keys that's been used in the sketches. N1 is the refractive index of the denser medium. N2 is the refractive index of the rarer medium. Theta 1 is the angle of incidence. There you can see theta 1 is the angle of incidence. And theta 2 is the angle of refraction. And theta C is the critical angle. That is the symbol for critical angle. All right, so when it's refraction, you can see that your angle of incidence is smaller than the critical angle. If your refracted angle there is 90 degrees, then you will know that this is a critical angle. If theta 1 equals, and make sure of a 90-degree angle there, then this is a critical angle. And sorry, total internal reflection is where the incident ray is bigger. The angle of incidence is bigger than the angle of the critical angle. It's bigger. If it is bigger, you will have total internal reflection. If it's smaller, you have refraction. If it's the same, you will have a 90 degrees angle, and that is your critical angle. Critical angle 02 is 90 degrees. So this angle makes sure the 90-degree angle is okay. All right. Total, what is total internal reflection then? Total internal reflection is if the angle of incidence is bigger than the critical angle, as we explained just now. We have a less dense medium, a less dense medium and a denser medium. So the conditions for total internal reflections are light is traveling from a more dense to a less dense medium. The angle of incidence must be bigger than the critical angle. All right, must be bigger than the critical angle, as we see here, and each pair of medium have their own unique critical angle. For example, the critical angle for light moving from glass to air is 42, and that of water to air is 48.8. So each and every medium is again does have its own unique critical angle. Right, the second part of today's webinar is about 2D and 3D wave fronts. Okay, as we explained, now that we do know that waves can be, or waves do have certain fronts. Okay, I'm not sure how many of your grade 10 work you can remember, but you should know already from your grade 10 work. You must remember what is pulse, amplitude, wavelength, frequency, period, and in phase. So what is happening in here? I'm looking here at a transversal wave, and you can see that from a crest to a crest, we have one wavelength. A trough to a trough, you have another wavelength. The Y that you see here, that is the amplitude. That is the amplitude of the wave. So what will then be the frequency? And what will be the period? The period is how many waves in 1 second. The frequency, we will look at that just now. So make sure that you do remember each and every one of these terms and how to calculate it. The first thing we're going to look at is interference. What is interference? That is also grade 10 work, just a bit of revision. It's a phenomenon in which two waves superimpose to form a resultant wave. So we have either constructive or destructive interference. Constructive interference is there where you do have two waves, or two pulses that are in phase, approach each other from opposite directions. Opposed opposite directions, two pulses that are in phase. Can you see from opposite directions? So A plus B will make a bigger wave. I'm not sure how many of you did visit the seashore. It's very interesting for me to just sit there on the sand and look and look and look at the waves. It's because no two waves will form the same constructive interference or destructive interference. It's depending about the way they approach each other and how big the waves are. And if the pulses are in phase, they will construct each other. So the amplitude will be bigger when the two of them meet, and afterwards they just move their separate ways again, but then you can see the amplitude is the same as what it was in the beginning. So pulses meet and the amplitude is the sum of the amplitudes, and after interference, the pulses continue in their original direction. So what is destructive interference then? Destructive interference is where you do have a pulse two pulses that are out of phase. Here you can see you have a crest and a trough that near each other before they interfere with each other. And the moment they interfere with each other, then there's nothing. Okay, and after that, I just move the separate ways again, as was in the beginning, but after they distract each other. Right, two pulses that are out of phase meet at the amplitude is the sum of the amplitudes, and here you can see they cancel each other out when they meet. Right, and afterwards they move again in their original direction. So now, what is Huygens principle here? Properties of waves. We have also refraction. The first one was interference. Now we have refraction. Now, what is refraction? All points on a wavefront act like a point source. Each one of these point sources act as secondary sources that produce small circular waves moving forward with the same speed as the wave. And the new wavefront is obtained by drawing a tangent to all the new little wavefronts. Okay, so what is diffraction? The ability of a wave to spread out in wavefronts as they pass through a small aperture or around a sharp edge. Here you can see where you have a big opening where the waves need to move through. You can see it does not bend a lot. When an obstruction is placed in the path of the wave bends around the obstruction. Can you see it bends around, and it will also bend around the side. So the smaller the opening, the more the waves will bend around the side. The bigger the opening, the less they will bend around the side. So the width of the opening, the degree of diffraction depends on the width of the opening. So as we see saw in the previous one, a wide gap, there will be less bending than in a small gap. The width of the opening, therefore the smaller the opening, the greater the degree of diffraction. And the degree of diffraction is inversely proportional to the width of the opening. As we saw here, inversely, bigger opening, smaller diffraction, smaller opening, bigger diffraction. So they are inversely proportional to the width of the opening, and the maximum diffraction occurs when the size of the opening is equal to the wavelength of the wave. So the wavelength, therefore the wavelength now, the degree of diffraction depends on the following. The degree of diffraction is directly proportional to the wavelength of the wave, so therefore longer wavelengths undergo greater diffraction. So the bigger the wavelength, the bigger the diffraction. All right. So we also have a diffraction of light. Since light has a dual nature, it does have a wave and a particle-like properties, and hence light is a wave. Light must be able to interfere and diffract. So this, what we did for waves now, we can also see in light waves. Here you can see waves bent around the side of the split. This is light source. Here's the wave is coming. There are two sources. That's why we have two types of waves here. The light intensity will depend on how the waves interact with each other, where they interfere with each other, how much interference they occur. If they do have distract or constructive interference, and that makes this color band here, where we have dark bands, and the first band will be the one that's in the middle, the bright central band. All right, now the last thing that I always put in my slides is the part of the resources that you do have. If it's the third time that you hear this, maybe I say something different today that you didn't think about. So let us just see. The first thing, the other learners, Doxa Insha, impact use Doxa Insha study guides and facilitators guides. But Doxa Insha also do have a lot of other resources that you can buy from them. They do have exercise books, and if you're interested in technical science, you can also order technical sciences exercise books from them. All right, they do have also past papers that you can order from them. You can go on their website and log on their website and see what do they have. That's very important that you can use for extra resources. The most important thing that you can use is the experiment videos. Now, Doxa Insha did all the practicals that's in the study guides. They did on a memory stick that you can order from them for 7 rand. If you think maybe you think it's expensive, but it's far more expensive to buy all the practical apparatus than just look at the experiments on the memory stick. The thing is, it's better to do the practicals. I know that, but if you don't have the resources and you cannot buy the apparatus, do yourself a favor and buy the memory stick with the practicals. Look at all the practicals, write the scientific reports. You will see the more you do the scientific reports, the better you get your scientific reports and the better become your understanding of scientific reports. Now, after each and every unit, you will see there's mind maps and summaries that summarize the work, and mind maps is just one paper or 2 papers that you can copy or take out of the study guide and put it on your door and learn them. Remember, when practicing for an exam or test, please use your summaries and your mind maps in order to prepare so that you do have enough time to work through as much as possible question papers. The question papers, you can either buy from them or that are the question papers that Doxa Insha I put as handouts for you during the webinar. Make use of them. All right, then one other resource that you received this year that's part of your package, this is the Impact Learners of the Quanta Physical Sciences books. It's a summary book with exam type of questions with 2 DVDs. This is very valuable because the DVDs, there are lessons on the DVDs. It's not long lessons. It's snippets of each and every of the most important parts of the curriculum that's been explained on the DVDs. Make sure that you do look at them. The grade 11 work, especially, there's such nice ideal gas laws animations. Go through them, look at them, and see the different graphs that's been explained on the video. I think it's 10 minutes. If it's 10 minutes, Moore's law and Gay-Lussac's law, all the laws that you have. And very valuable is the multiple choice step-by-step explanations for the multiple choice questions that you can look at after you do the multiple choice questions. Now you can ask me, now what am I supposed to do in this? There's such a lot of work to do each and every day. When do you think I'm going to have time for this? Now, lesson learners, what's very important here is it's been separated, all the different questions. It's different from a question paper that you download from the internet. You do have here questions about mechanics. You do have questions about the different topics under mechanics. The same with the knowledge area, wave, sound, and light. You have different topics there, etc., etc. So it's easier for you to work through them. Do 2 or 3 multiple choice questions per day. The more you do, the more you get fit for multiple choice questions. Because if you look at the explanations at the back, you will see some of them do not have explanations, and the reason for that is if it's theory, and there's no explanation, it's theory. So make sure that you do know your theory and look up your theory if you do have a theory question wrong. All right, and there's a lot of application questions, so please make sure that you work for your quantum book. That's part of your package this year. And the last thing is Science Clinic. Now, Science Clinic does have notes for free on their website that you can download. And please make sure that when you download it, that you state that you are from Impact. Download the summary. There's also this is very this is really a very good tool during exam preparation. We're going quickly through your work, going through the calculations, and start doing your questions in the quantum book and exam papers. I did talk to James Hayes from Science Book yesterday. He said to me they load a lot of sessions during this year on their website yesterday. So log onto their website and register for the courses. However, how they're going to do it, it's for them, and you have to register for them. But please make sure that you register as one of Impact's learners. The reason for that is that they gave the Impact learners some of it. We do have discount. They do have discount prices for Impact learners if they register early enough. So make sure that you make, and so the other reason is that you can easier see where there's a center near you, or I'm not sure if they're also going to give webinars or whatever they're going to do. Go on their website, not on their website, for the seminar, exam seminars and work sessions. Okay, again, if you do have any questions, make sure that you write the questions now. And if you didn't write any questions and you do have questions, send your questions through to Academics at Impact or info@impact.co.za. Thank you for joining me today, and have a really nice weekend.